Good morning. I hope everybody's doing well. I wanted to take some time while I'm at home to make some videos to review materials from Unit 6 and Unit 7. So I'll be slowly getting those up on Canvas. If you go through the materials or the resources that I've put on Canvas and you feel like you're ready to reassess, just send me an email and I will kind of discuss options with you for reassessment on Unit 6 and or Unit 7. And there's also a couple of you who might want to do Unit 5. So just let me know if you feel like you're ready and we'll kind of figure something out. But today I'm going to go through discovering or verifying trig identities. I don't know that I'll get it all in one video, but I'll do my best. It might be kind of long, skip around, use what you need, try them on your own. Again, send me an email if you need help. Okay, fundamental trig identities, these are the ones you need to have memorized essentially. We haven't been using even odd identities much, but they are there. Biggest ones are knowing your reciprocals, your quotients, and your Pythagorean. And then just remember, even if we have sine squared plus cosine squared equals 1, if I subtract cosine squared to the other side, I can also have sine squared equals 1 minus cosine squared, or cosine squared equals 1 minus sine squared. Some guidelines for verifying trig identities. Work with one side of the equation at a time. It is often better to work with the more complicated side first. Look for opportunities to factor an expression, add fractions, square a binomial, or create a monomial denominator. Look for opportunities to use the fundamental identities. If the preceding guidelines do not help, try converting all terms to sines and cosines, and I would actually recommend looking at that first potentially. And then step 5, don't be afraid to stop and start over again if you're not getting anywhere. Strategies leading to dead ends might give you some good problem solving ideas for later. For some reason, my pen doesn't want to cooperate today. So let's go to the next problem. Okay, let's see if the pen will work this time. So we're going to verify our first trig identity. So we have secant of x times cotangent of x equals cosecant of x. If I rewrite this as 1 over cosine, and cotangent is cosine over sine, I can actually simplify my cosines. So I'm left with 1 over sine of x, which is the same as cosecant of x. Okay, so I can just bring that side straight down. It didn't change at all, but I just verified the trig identity. There's one there for you to try. So go ahead and hit pause, see if you can follow the same process. When you're done, move on to the next problem. Okay, next one, verify the identity. Sine of x times tangent of x equals, or plus cosine of x equals secant of x. I'm actually going to rewrite this as sine over cosine. I'm not changing the right side at all. If I simplify, I get sine of x, sine squared of x over cosine of x plus cosine of x, and I'm going to multiply by a fraction to get common denominators. So I now have sine squared of x plus cosine squared of x over cosine of x. And remember, I'm actually going to go backwards. Sine squared of x plus cosine squared of x is 1. So 1 over cosine of x is secant of x. Okay, so there we combined fractions with common denominators, used an identity. Oh, and also rewrote as sines and cosines. Again, hit pause, try the next one. You think you're good? Move on to the next example. Okay, example 3, verify the identity. Cosine minus cosine sine squared equals cosine to the third. I notice that I have two things in common here. So I really have two terms and they both have a cosine. So I'm going to take out a cosine, which is the same thing as factoring out a GCF of like 2. So cosine divided by cosine is 1. If I take the cosine out of the second term, I'm left with just a sine squared. And then 1 minus sine squared is coming from this Pythagorean identity. If I were to move this over, cosine squared is equal to 1 minus sine squared. So I'm going to replace that 1 minus sine squared with a cosine squared. So I end up with cosine to the third of x equals cosine to the third of x. Again, go ahead and hit pause. See what you can do there. Try the next one, very similar. And when you're ready, move on to the next problem. Example 4, you have a couple options. You can work on the left side, you can work on the right side. It does not matter in any of them, actually. It's up to you. If you're going to do the right side, rewrite this as 1 over cosine and sine over cosine and combine them together. I'm going to split this up, 1 over cosine of x plus sine of x over cosine of x. So 1 over cosine is secant, and sine, I missed an n, sine of x over cosine of x is tangent of x. So we get secant plus tangent. Okay, again, try that problem. When you're ready, move on. Okay, getting a little bit more complicated here. I need to actually combine these together by finding common denominators, or you can start on the right side, but I'm going to start on this side because it's more complicated. So I'm going to multiply the first fraction by cosine of x times over cosine of x, and I'm going to multiply the second fraction by 1 plus sine over 1 plus sine. So when I do that, I end up with cosine squared of x over cosine times 1 plus sine of x. Let's do the next one there. And then on the right side, I end up with the same denominator. And I'm not going to distribute because I'm hoping to cancel some stuff. But on the top, I do need to distribute. So if I do 1 times 1, 1 times sine, 1 times sine, and then sine times sine, which is sine squared, I end up with a common denominator, and I can simplify. So if I look at this closely, I'm going to use a highlighter here. Cosine of x and sine of x is 1, and then I can combine 1 together with the other one. So cosine of x, sine of x, cosine squared of x, sine squared of x is 1, and then this is going to be 2 sine of x. So I end up with 2 plus 2 sine of x over cosine of x, 1 plus sine of x. I'm just going to keep going this way so I have room. I'm going to factor out a 2. So I have 1 plus sine of x over cosine times 1 plus sine. And these cancel. So I end up getting 2 over cosine, which is the same as 2 times secant, which is what we needed. Again, hit pause, try that problem, make sure you're with me on that, and then move along. Okay, next one, you have a couple options here. I'm actually going to, I want sine in the denominator, so let's see how we can do this. What if we multiply by 1 minus cosine of x over 1 minus cosine of x? The reason I want to do that is because if I multiply this out, these are conjugates, so I end up getting this. I get 1 plus cosine of x minus cosine of x minus cosine squared of x. So these cancel each other out. And 1 minus cosine squared of x is the same as sine squared of x. Okay, now if I have a sine of x in the numerator and sine squared of x in the denominator, one of the ones in the denominator cancels, so I'm left with 1 minus cosine over sine, which is what I need. Again, hit pause, keep trying them. The more you do them, the easier they're going to get. When you're ready, move on. Next problem. We have a couple options here, and I'm actually going to flip back here for a second because we have sine of negative x, and like I said, this isn't one that we see very often, so I'm going to just pop this back up here. Your even and odd identities, sine of negative x is the same as negative sine of x, and that has to do with the symmetry of the graph. So sine of negative x equals negative sine of x. So I'm going to go ahead and start by replacing that. Make it a little bit easier. So tangent of x, this ends up becoming a plus sine of x. I don't really need to see it around it now. And then we just kind of need to decide where we're going to go from there. When I do these, there's not always one correct method to use, so keep that in mind. Let's go ahead and do sines and cosines and see what happens. Let me get my pen back. So I have sine over cosine, and I want to combine that. I'm going to multiply this by cosine over cosine so I can have common denominators. And I'm just going to worry about the numerator right now. So if I combine those together, I get sine plus sine times cosine over cosine. And I'm going to factor that. So I'm going to get sine times 1 plus cosine over cosine divided by 1 plus cosine. Don't want to lose that. Now, instead of dividing by a fraction, we typically multiply by the reciprocal. So my next step would be to take this and flip it. So I'm going to do sine times 1 plus cosine over cosine. And then I'm going to multiply by my reciprocal, so 1 over 1 plus cosine. And those cancel. So I'm left with sine over cosine, which is tangent. Okay, that one's a little bit more complicated. Practice this next problem and then go do the practice problems and let me know if you need help. I will be posting the answers to some of these homework assignments here soon, especially the extra practice. Please let me know if you have any questions. Reach out. I can help you. We'll figure out a way to get this done even though we're not at school. Have a great day. Stay healthy. Stay safe. I miss you guys.